Okay, 2014 question 7. You can see from the sketch it's looking like it's going to be a window, so we'll have a read through it and see what the important words are. The sketch shows a wooden casement window fitted to the external wall of a dwelling house. The window, which is 800mm in height, is triple glazed, high performance window with a thermally broken insulated frame. The external wall is a 400mm concrete block wall with a 200mm full fill insulated cavity. The wall has an external render and an internal hard wall plaster skim finish. To a scale of 1 to 5, draw a vertical section through the wall and the centre of the window. The section should show the typical construction details from 300mm below the windowsill to the fixed frame of the window to a level 450mm above the window head. Include 3 typical dimensions in your drawing. Indicate clearly on your drawing the typical design detailing to prevent the ingress of water at both the window head and sill. So we'll look at part B at the end. Now, we'll underline some of the important words and explain a few bits that need to be explained. The sketch shows a wooden casement window. Now, when you see a casement window refers to a window like one of these. A window that basically has a part that opens out. It could open out to the side, it could open out from the top. That one there opens from the top. Either way, it's got a frame and it's got those like little doors nearly in the window that open up. So you're referring to a window when you're drawing this. For example, at the bottom you would have your window frame, which is fixed to the wall, which would essentially, what we've done there would essentially be like the bottom part. And then if you remember drawing, this little piece here would be these parts here that open out. So a casement window, you're drawing something like that. If it doesn't ask for a casement window, we usually just draw a fixed frame window like that, and that works fine. But in this case, I've asked for a casement window, so we've got to have the fixed frame and the part that opens out of that window as well. So fixed to an external wall of a dwelling house. The window is 800mm in height, so that's going to be important. You've got to stick to that. And is a triple glazed, high performance window with a thermally broken insulated frame. So we're well used to drawing those at this stage. Triple glazed, high performing, thermally broken frame. No problems there at all. The external wall is a 400mm concrete block. So we're not dealing with timber frame here. We've got a concrete block with a 200mm full fill insulated cavity. So the full cavity is insulated here. The wall has an external render. There's plaster on the outside and an internal hard wall plaster skim finish. So basically that means it's plastered on the inside as well. Okay. To a scale of 1 to 5, draw a vertical section through the wall and the center of the window. The section should show the typical construction details 300mm below the window sill, through the fixed frame of the window to a level 400mm above the window head. Include 3 typical dimensions in your drawing. Alright, so we'll look at part B at the end, as I said. A bit of manageable one. We've dealt with windows quite a lot at this stage. We will start with the bottom of the window and we'll draw the wall and we'll start to build in the window sill and so on there. So, just the bottom left corner of the page. It's scale 1 to 5, so let's draw the wall first of all lightly. 100mm external leaf, 200mm cavity, and a 100mm external leaf. That's going to be quite big because 1 to 5. That works out, when you scale it down, that works out at 20, 40, 20. Now I'll extend up a little bit more. Make sure that you get your 300mm below the windowsill level. So what I would do there is lightly, obviously, everything. And I'll draw 2 blocks in. That'll cover me well over 400mm. So a block there and a block there. As we know, a block is 225, so that gets us about 450mm below. Now, that's all drawn in lightly. The next thing that I will do is I'll draw my windowsill into position. The windowsill, as we know, they can vary in size and shape. Generally, I like to stick to 100 millimeters down and 210 across. That's the way it is in the book. The windowsill can be done in a couple of different ways. In this case, I'm going to rest the windowsill on just the external leaf. So if I come across about maybe about halfway through the cavity, come down your 100 millimeters, go across your 210. Obviously, when it's scaled down. And this measurement from there across, you can just make your own judgment on that to get those sizes correct. And that'll be fixed into place with some mortar at the bottom so it won't move. A cavity closer you can put there if you like, just a little bit of rigid insulation. We don't always do that, but you can do that if you like. And then we've got a full fill cavity insulation all the way to the bottom there, as the question is stated. Before I go and draw the window in, I'm going to draw the top part of the wall. So lightly extend this work up. The question tells us the window's height is 800 millimeters, so scale that down by 5 and measure up your 800, whatever that works out at. Draw across there, and that is going to be the top of the wall. Now it's a concrete block wall, so we are going to have a lintel here. So up your 75, that's your reinforced steel in the lintel there. Okay, and we've got our insulation, our full fill insulation going all the way down there. Again, because it's such a wide cavity, you can put a cavity closer in there if you like. I'd recommend. So about 50 millimeters up for your cavity closer. They can vary in size also. And then your insulation will go all the way up. When it's full fill insulation, they pump in that soft insulation there. That's why we're using the soft insulation, symbols for that. Draw in 1 or 2 blocks. Again, it says to go 450 millimeters above. So if you go 2 blocks and a little bit more, you're well covered on your 450 there. Next, we can draw in our window frame then at this point. Again, it doesn't give us any sizes for the window frame or the parts that open out, so we can kind of use our own judgment on that. You can start really within reason anywhere across there with your window frame. Just for handiness sake, I'm going to start just here level with the edge of the windowsill. We usually make our window frames 80 by 150, so we're going to stick with that. 70 or 80 by 150. Draw that fixed frame there. I'm going to lightly extend that up and draw the fixed frame in there. So 80 by 150. Alright, they are the 2 bits of the window frame that are fixed to the wall. Next is a little bit that opens out. So if you want to make your own judgment and cut a little slot out of there, I'm going to roll out some of these lines now to start avoiding any confusion we're going to get. Cut your slot out of there and do the same down here. And into that you can fit a smaller little frame, usually 60 by 60 roughly is what I like to go for on that. Something roughly in shape like that. Again, you can use your own variation on that because as we know, depending on your manufacturer, the shape of those frames can vary. Obviously try keeping the same size. My sketch, they're not exactly the same shape and size, but go with something like that. Alright, I like to go roughly 60 by 60 with these and 150 by 80 for the fixed frame. If you want to add your own little angles to those, which is often done, you can. That makes them look a little bit more professional as window frames. From there, we've triple glazing that's going to fit in here. So there's 1 layer of glazing. I'm going to be tight for space on my sketch, but as you all are aware, I'll just do 2 for the sketch. There's 2, it should be triple. Try and squeeze another one in the middle there. So obviously the size of this here, make sure you can fit 3 layers of glazing into place there. Alright, and that's pretty much it. It's one we're quite familiar with at this stage. DPC and so on needs to come in. So TPC across there, down there and over the front. There's DPC wrapped around the underside of the full windowsill. There's a little drip if you want to draw that in there. It stops water from travelling all the way across there. And that's pretty much it. We'll just have a look at part B there. Part B says indicate clearly the typical design dealing to prevent the ingress of water both the windowsill head and the windowsill. So the windowsill, to stop water getting in, we have DPC on the bottom of that, and we have that little drip, and at the top we have the DPC across there. Alright, that's pretty much good. So we'll have a look at the final solution, which might show up any other bits that I might have forgotten. So here's the full final solution. The bottom section. Thermally broken frame was mentioned in the question, which I actually forgot on the sketch. A little bit of insulation in the frame. Use your own judgment on the size of that insulation. You have triple glazing all the way up there. You've got a cavity closer, which I mentioned, your DPC and all that. I forgot in the sketch to include the external render and the internal plaster. External render is usually around 18 millimeters within reason. Internal plaster around 12 mil. Alright, and usually that plaster will go down underneath there and underneath there. So make sure you don't forget the external render and internal plaster. So that's the full solution there. A very manageable one. Oh, part B. Position of DPC shown helps to prevent the ingress of water in both positions. So that DPC going down there helps prevent the water getting across the cavity and helps it prevent it going up through the windowsill. So have a go with that question.